ladies and gentlemen.
Welcome everyone, let's talk complex numbers. So complex numbers are numbers that are made of a real part and an imaginary part come together. So what that typically looks like is a plus bi, where the a is the real part and this bi is the imaginary part. So speaking of imaginary parts, imaginary numbers do exist. I want to specify that now. They do exist, and they are numbers whose square is negative. So if I square an imaginary number, I get a negative real number. The imaginary unit, which you've clearly seen here, is I. And I is just the square root of -1, which means that I squared is -1. So let's simplify some expressions and see how imaginary numbers, complex numbers, real numbers, they all work. So if we're simplifying radicals like this, typically we could use a lot of different rules with radicals, but with imaginary numbers specifically, we have to be very careful. If we have multiple radicals like we do in C, we have to try to simplify each one as much as we can first before we combine them. So one radical here, I can split this into -1 and 9. The square root of 9 is 3, and the square root of -1 is I, so the answer here is just 3i. Not too bad. This one here is a little bit different. I can split this up into 3 parts. I can split this up into -1. I can split this up into a square, which is 4, and then a random 3 that just got thrown in there. So the square root of -1, the square root of -1 is I. The square root of 4 is 2, and the square root of 3 doesn't simplify. So we're just left with 2i square root of 3, which is perfectly fine. Here is where something interesting happens. So a common mistake would just be to multiply these two things together. We get the square root of 60, and then going from there. But if you do that, you miss out on a lot of information. So that's not actually allowed when we have negatives under the radical. So if I have this here, I'm going to simplify this one. Same steps as before. 6 is 2 times 3. Neither of those are squares. So this is just I square root of 6. 10 is 2 and 5. Neither of those are squares. So we have I square root of 10. Now I can multiply the i's together. So I have I squared. And I can multiply the square roots together, giving me the square root of 60. Now 60 is 2 times 3 from the 6, and then 2 times 5 from the 10. So I actually have 4 times 3 times 5, or 4 times 15. So I have a square part and a non-square part. So I'll split that up in a second. I squared is just -1. So the square root of 60 is going to turn into the square root of 4 times the square root of 15. Multiplying all of those, we get -1 times 2, which is -2 square root 15. So not too bad. You just got to be a little bit more methodical of how you go about solving and simplifying with imaginary numbers. If we want to perform operations between complex numbers where we have real and imaginary parts, they act as different terms. So before I told you that we can only combine terms together if they have the same variables in the same amount. Well, i's and things that don't have i's don't interact. Real numbers and imaginary numbers don't interact through addition and subtraction. They can through other operators, but not addition and subtraction. So when I simplify this, I'm going to distribute the 5, and that's okay. You can multiply real and imaginary together, and that's perfectly fine. So 20 plus 8i. That I does not look nice. Let's better. And then this just drops down. No need for those parentheses. Combine our like terms. 2 plus 20 is 22. 3i plus 8i is 11i. And that is simplified. Again, the real part and the imaginary part do not combine there. Multiplying is a slightly different story. You're allowed to multiply real times imaginary, imaginary times imaginary, real times real, so on and so forth. So this we're going to distribute like we would before, where I like to make a little cut between each of the terms, separate them, so 2 and then plus 7i, and then each of those gets the 3 minus 2i. Now I can distribute. So if I distribute this 2, I get 6 minus 4i from the left one, and the right one, I get plus 21i and negative 14i squared. Now remember that I squared, this is just a negative 1 in disguise. So this is just a positive 14 in disguise. So 6 plus 14 is 20. And then negative 4i plus 21i would be a plus 17i. So not too bad. Division's a little bit different. I can't divide by an imaginary number in the conventional sense. I have to multiply my fraction, numerator and denominator, by the imaginary part. So if I have 3 divided by 4i, I'm going to multiply this, numerator and denominator, by that 4i. Why? Because it's improper to have an imaginary number in the denominator of a fraction. And doing this, we will end up with a real number solution down there. So 3 times 4i is easy, that is 12i. And then 4i times 4i is 16i squared. Remember that I squared is just negative 1, so this is just negative 1. And I can simplify this a little bit. 12 and 16 have a common factor of 4. Canceling that out, we would end up with 3i over negative 4, or we could just rewrite this as negative 3/4 I. Not too bad. A lot of weird rules, though. Now, if I'm dividing by a complex number, not an imaginary number, but a combination of imaginary and real, I have to multiply by the complex conjugate. A conjugate is the two separate parts of the difference of squares. If you remember, if I have a squared minus b squared, that this factors to a minus b times a plus b. It doesn't matter which one's first. Order doesn't matter with multiplication, right? But each of these parts are called conjugates. And when I'm dealing with complex numbers, they're called complex conjugates. So we're going to multiply by the complex conjugate. In doing so, we actually cancel out that imaginary term in the denominator. So we're going to take this, it's 4 over 2 minus 3i, and we're going to multiply this numerator and denominator not by 2 minus 3i, but by its conjugate, 2 plus 3i. Remember, we need to multiply by the same thing to the numerator and denominator because we don't want to change the value when we're simplifying. So this one's easy. 4 times 2, 4 times 3i, we get 8 plus 12i. The denominator, a little bit different. I'm going to simplify it down here. Remember that I like to cut them apart, so I have 2 minus 3i, and then each of those gets the 2 plus 3i. We're going to distribute from here. 2 times 2 is 4. 2 times 3i is a positive 6i. Negative 3i times 2 is a negative 6i. Negative 3i times positive 3i is negative 9i squared. Keeping in mind that I squared is just negative 1 in disguise, we have some weird stuff going on. Positive 6i, negative 6i, those cancel. And then negative 9 times negative 1 is a positive 9. 4 plus 9 is 13. So all of that condenses completely down into a 13. Now, we can keep it like this, but I like to distribute into my division, so I have a complete separation between my real and my imaginary parts. So I'm going to do 8/13 plus 12/13 I. Both of these, again, are correct, depending on how far your teacher wants you to take it. They're both completely the same. If you have any questions with anything, let me know. Otherwise, I'll see you in the next video.